Welcome to Selection Sathi. Today we learn about greedy algorithms, a technique where we make the locally optimal choice at each step hoping to reach a globally optimal solution. Greedy is faster and simpler than DP, but it only works for certain problems. We will understand when greedy works, when it fails, and solve classic problems like activity selection and Huffman coding. The greedy choice property is what makes greedy algorithms work. The idea at each step, pick the choice that looks best right now. Do not look ahead, do not backtrack, commit to the choice and move on. For this to work, the locally optimal choice must be part of some globally optimal solution. This is not always true, and that is why greedy does not work for every problem. To prove a greedy algorithm is correct, you must show that the greedy choice is always included in an optimal solution. The second property greedy needs is optimal substructure. After making the greedy choice, the remaining problem must have the same structure as the original. Combine the greedy choice with the optimal solution to the remaining subproblem and you get the global optimum. Activity selection is a great example. After picking the activity that finishes earliest, the remaining activities form the same selection problem, just smaller. Both greedy and DP require optimal substructure, but greedy additionally needs the greedy choice property. When does greedy work and when does it fail? It works for activity selection, always pick earliest finish time. It works for fractional knapsack, pick by highest value to weight ratio. It works for Huffman coding, always merge the two smallest frequency nodes. But it fails for 0-1 knapsack, you cannot split items, so the value to weight ratio greedy can miss the optimal combination. It also fails for the traveling salesman problem and for coin change with non-standard denominations. How does greedy compare to dynamic programming? Greedy is faster, typically O of n log n for sorting plus a single pass. DP is more general but slower, it fills an entire table. Greedy makes one choice and never looks back. DP considers all possible choices and picks the best one. The rule of thumb, try greedy first because it is simpler and faster. If greedy does not give the optimal answer on small test cases, switch to DP. Activity selection. We have 11 activities with start and finish times. Sort them by finish time. Pick activity A, finishing at 4. Next compatible activity is D, starting at 5, pick it, finishing at 7. Next compatible is H, starting at 8, pick it, finishing at 11. Next compatible is K, starting at 12, pick it. We selected 4 activities, A, D, H, K, this is the maximum possible. The greedy approach gives the optimal answer. Fractional knapsack. 3 items, weight 10 value 60. Weight 20 value 100, weight 30 value 120. Capacity is 50. We can take fractions of items. Calculate value per unit weight 6, 5, and 4 respectively. Sort by ratio in descending order 6, 5, 4, take item 1 fully 10 kilograms, 60 value. Remaining capacity 40. Take item 2 fully, 20 kilograms, 100 value. Remaining capacity 20. Item 3 weighs 30 but only 20 capacity left. Take 2/3, 20 kilograms, 80 value. Total value, 60 plus 100 plus 80 equals 240. Huffman coding. Characters with frequencies A5, B9, C12, D13, E16, F45. Step 1. Merge the two smallest, A and B, to get a node of 14. Step 2. Merge C12 and D13 to get 25. Merge 14 and E16 to get 30. Step 3. Merge 25 and 30 to get 55. Finally, merge F45 and 55 to get the root 100. Resulting codes, F gets code 0, the shortest since it has the highest frequency. A and B get 4-bit codes, the longest since they are least frequent. Total weighted path length is 224 bits. Coin change with coins 1, 3, and 4 for amount 6. Greedy approach, pick the largest coin first. Pick 4, remaining 2. Pick 1, remaining 1. Pick 1. Total 3 coins. But DP finds a better answer. 3 plus 3 equals 6 using only 2 coins. Greedy gives 3 coins, DP gives 2. Greedy is not optimal here. Why? Because these coin denominations do not have the greedy choice property. With standard denominations like 1, 5, 10, 25, greedy does work. This is a classic gate question testing when greedy fails. Quick exam tips. First, greedy only works when the greedy choice property is provable. Second, in activity selection, sort by finish time, not start time. That is a common mistake. Third, fractional knapsack is greedy, 0-1 knapsack is DP. Gate loves this distinction. Fourth, if greedy fails on a small test case, do not waste time, switch to DP immediately. For more concept videos like this, download the Selection Sathi app. Like and subscribe. Thank you.